Hey, what's up guys? This is Krishna here. Welcome to the project walkthrough of Houdini Spiderweb. This project I created for Side Effects Martini 22 challenge, day 1, called Curve. Okay, so obviously I'm using the node Curve in this one. Okay, the project file is available for free to download from gumroad.com. If you feel generous, you can of course donate towards that file. But either way, it's available for free. Let's jump right into it. So I've got a web container here and some of the rendered containers. Okay, so let me go through the web first, which is where everything happens really. So I've got a curve. So there's the front view. I've got a curve. It's just a simple curve. It's no big deal, and this setup is particularly for curve. So if you put in a circle, for an example, this may not work. Okay, so you can give it a shot, but it's set up for curve. So you can add more curves and whatnot if you want. All right, or different type of curve, etc. Okay, so it's just a simple curve, and then I'm converting that to line. So down here you can see it's 24 prims after convert line, but before that it's just one primitive. Okay, so I'm converting that, and then I'm creating a group called circles, and that's a point group, and then I'm smoothing out the curve, and then I'm creating a join node, which if you notice here it's gone back to one primitives. Okay, and I'll explain why that is later on in this walkthrough. Okay, and then I'm creating concentric circles by copying the same 37 times, increasing the scale by 1.1. okay, so if this was just one, you won't see anything. So 1.1. okay. So on this side here, so I've got a line in the X direction. Okay, it's important because if you have it in any other direction, I think it defaults to Y, but change it to X direction, and I'll explain that shortly as well. So I'm creating a group here, which is a point group called lines, and then I'm promoting that group and calling lines in the primitive group. Okay, and I'm keeping the original group. I suppose I could have just created another group with primitive group, but anyway, it doesn't matter. So I'm copying those lines across to the curve, okay, before converting or anything. And this copy to curve is where this line, if this is facing, let's say by default X, you'll get this. Okay, that's not good. That's why I changed it to X. All right, so you can get it around the curve. Okay, so there's the curve, and it just goes around it, which is perfect. It's 10 meters in length. I'll explain that later as well. Okay, so just let's keep all of this in mind. And then I am dissolving it. So if without it, so this thing disappears. Okay, I mean you don't need to do it, but I'm cleaning it out basically. Okay, and then I'm transforming this slightly smaller, and I'll explain this why as well later. Okay, that shouldn't be green. If you want to change the color to its normal color, you go to actions and use default color. Okay, so next I'm merging the two, so to create sort of a spider web kind of thing. All right, and if I don't have the smooth, it'll look like that. Okay, so that's what that is, and I'm resampling it. So currently it's all evenly spaced out. Okay, without it, it won't be. Okay, so it's better off for you to resample. I always choose the curve view just in case if I need it. In this particular project I didn't need it, but I enabled it anyway. And then I'm again transforming it to make it even smaller, and I'm creating some wrangles here. Okay, so basically I'm creating distance, which is the length of position. Position is a vector attribute, and when you do a length of a vector, you get one value, which is a float value. Okay, so that basically represents the distance of each point from its center. Okay, so let me just disable that for now. Disable this. So if I put in a color node here and ramp from a attribute, and I'll call distance. As you can see, the closer to the center, it's darker. The further away from the center, gets white. Okay, so that's basically it. If I change this to red, for example, there it is. Okay, so that's what that basically is. And I don't really need these two nodes. What I'm doing here anyway is that I'm creating a group just to focus on the center parts here, just in case if you got any trouble, okay? You can delete them or do whatever you want, all right? And the next one is from the drop down here, okay? So which is the nearest point distance. There it is, that one, okay? It's basically the same thing. The way I did it earlier with the color node, it's what this is. I think I'm using this center group elsewhere, okay? We'll check it out. Anyway, I'm resetting the color back to white, okay? And this node you definitely do not need, okay? But it's there. Okay, so then I am copying. Let's see here. So I've got okay, I'm going to explain this side here, right? So I got a box here. Originally, I submitted this as an image, okay? Now I've created a video out of it, but the original image was rendered with this box, okay? This is supposed to be a glass box, and the web was supposed to be inside of it. But during the animation or the clip rendering, it took a long time for me to render each frame. So I kind of ditched the box. However, you do need the box anyway. So let me explain what's going on here. So I got a box, just 2 divisions or whatever. And then I'm matching, using match size to fit the scale and justify it to minimum. So it sits on the ground plane, okay? And I've also adjusted the target size here. So make it slightly longer or taller. And then I am creating a peak reverse direction so that I can scatter some points, because if you scatter points on the outside, you know, yeah, I didn't want to do that. Okay, and I'm just randomizing attribute, which is a 4-dimensional attribute, okay? And I'm choosing inside sphere. Yeah, these are all normal. And then I'm also randomizing p-scale. P-scale value would be between 1.1 to 1.5, and a probability of 50% each, okay? So that's what that is. And then I'm copying that across, and we will get this. So we're copying all of this one to all of these points, okay? The reason why I created this peak is so that these webs stay inside of the box, okay, not outside. And what I also do is that I actually group the ones that are falling inside of the box, okay? And then I merge the box in. Let me explain that shortly, but basically if I remove that and connect that here, I'm deleting that group. Basically, these are the points that I want to keep, and I'm deleting everything else but the group keep, okay? So we end up with this, okay? So I was mentioning earlier, I want to show you the join, okay? So notice these things here, these lines here. If I remove the join, they'll disappear, okay? But it brings its own issues, okay? Of course, it looks better without it, but if you remove the join, it brings its own issues, okay? And by the way, this is my way of doing it. I'm sure there are hundreds of other ways, you know, you can get, you know, you can achieve this. So anyway, so that's one of the things about join, okay? And I'll show you later as well, further down the line, why I put that in there, okay? So we got the copy to points, we got the group, and on this side, I'm creating another group here for the box, and then I'm using labs thicken just to thicken it up. If I go into, yeah, there you go. So that's what that looks like. So it looks like a very thick glass sort of thing. And then I'm beveling it, and I'm creating a collision source with the voxel size of 0.02, and creating a null for the outbox, because on this side it's the VDB, okay? And down here I have method 1 and method 2, and this is used for method 1 only, okay? I'll explain those as well, okay? So we got the group, we deleted it, and down here I'm deleting the lines primitive group, while keeping just the lines primitive group, because what we want to do, and this is for method 2 this is for method 2 and this is for method 1. Okay, maybe I should just put that in here. Okay, so so what I'm doing here is that I'm isolating lines primitive group. Okay, so basically get rid of the concentric circles, and then for each primitive, let me get rid of that. I'm selecting a group called pins. Okay, so if you now look at this, that particular line, okay, it's down here, right? But we want the opposite end of that. Okay, because if you want to pin it to the box, you want the opposite end of that, not here. Okay, so I created a sort node and I reversed the point sort, and guess what? Now it's selecting that side. Okay, so that's basically what it is, and now we've got a whole bunch of pins here. Okay, so that's what that is. Good. And then I am transferring that pins group into this line, which is the primary line here. Okay, so let's go through the first method, which does not involve this. So what's happening here is that first I'm creating vellum string. Okay, this, I know it says hair. I tried it out with hair, but it didn't work out very well. So I've got vellum string. Before we continue any further, as a matter of fact, I need to plug this in here. Okay, so what I wanted to do was I want to bring the scatter down to 1. So we just quickly establish what's going on. All right, and if I now template the box, you can see this particular web is down on this corner here. Okay, so let me have a look at it this way. Okay, good. So I create vellum strings. Okay, and then group type would be points, and I'm creating calculate varying mass based on the distance attribute we calculated earlier. Okay, and thickness is not necessary for you to calculate varying, but I did it anyway. I don't think it made any difference, to be honest with you. Okay, next, I've given really high stiffness value, 10 and e to the power of 10, and then bend stiffness as well is the same, but the damping ratio I increased it because I didn't want any jitter actions in here. Okay, so that's what that is. Next, move on to the stitch, second one. So there are 2 stitches here, as you can notice. There are 2 stitches, one for lines and then another for circles. Okay, the concentric circles. So stiffness for the lines is again very high stiffness, because I want these to be stiff, basically. Okay, and the damping ratio is also very high, so I don't get any damping problems or jitter problems. And then I reduce the rest scale to 0.4, so it kind of pulls in a little bit and gives it that web, spider web look. Okay, when you initiate the simulation, what will happen is the rest length will reduce and in turn pull all of these strings together. Okay, you'll notice that later. Okay, so that's that, and then I'll move on to the next one. And for circles, it's again the same stiffness, but the rest length scale is slightly different. Okay, it's twice more compared to the actual lines themselves. Okay, that's what that is. Nothing else changed here, except for the damping ratio is a little bit high. Maybe you can play with these, settings. It's fine. Next is Vellum Attach. This is the first method. Okay, so in this method, you definitely need this here. Okay, and I'm bringing that in. I mean, you don't need it, to be honest. I think I actually created this. In fact, I created this because I used a dock network earlier when I was trying it out. So in effect, you don't need this, but anyway, it's there. Okay, so what is this doing? I'm attaching the group keep, and the target is lines. So okay, and I'm attaching it to the target geometry, which is what we're getting in here. Okay, we're supplying it from all the way here down, all the way down here. Okay, and the stiffness is default, I think, this one, and I increase the damping ratio. Okay, I think damping ratio by default is 0.001. I didn't want that, but again, you can play around with these, so should be okay. And finally, I'm using Resblend. Resblend kind of smooths out the creases we get. I'll show you without it, and I'll show you with it. Okay, so I've given it a blend of 0.8. All right. Okay, so let me run this now, and I'll come back. Okay, I ran 48 frames. Okay, let's check it out. Yeah, I think that looks pretty decent. As you can see, these strings are kind of dangling and sliding, but because this was an extreme close-up shot, none of that mattered really, but there you go. However, I do want to point out that these lines and circles are sticking together as they should, and it's kind of pulling in a little bit because of the rest length, emulating a kind of a spider web. It's been a long time in there and whatnot, so that's what that is. Now I will show you without the rest blend. So there you go. It really got messed up here now, as you can see, and the reason why this is pulling out is because of the mass, okay, that we defined earlier up here. So it's because of this mass here. So the closer it is to the center, the lower the density is, and the further away from the center, the higher the density. Okay, and that's why it's behaving this way, which is quite cool. But without Resblend, it won't work very well. Okay, as you can see. So if I run it at this angle, I kind of liked some of these dangling lines a little bit as well. Not everything is kind of holding on to their pinpoints, whatever. Okay, so that's that. Okay. And I will not increase it back to 16 scatter points yet because I want to go through method 2. Method 2 is pretty much the same for these things here. Okay. These are all the same, except you can see here Vellum Attach node is no longer on in method 2. Okay, but I am still using blend. The only difference is in Vellum Hair I'm using pin to animation, and that is the pin group we created here. Okay, so what I'm doing here is that I'm using that as our pin points, and I'm creating a soft pin type, not permanent pin type. It's instead it's soft. Okay, so it has a little bit of wiggle room, if you know what I mean. Okay, so let me run this one, and you notice that these lines will here adhere to their pin positions. Okay, there you go. They're sticking to them, and it's not moving that much, and it's a lot more stable. But either way, I liked both methods, and that's why I'm showing you both methods. In fact, I didn't actually use two methods for the original file, but anyway. So there you go. So this is the video I showed you at the start of this walkthrough, where method 1 and method 2. So there are the differences, and you can choose to do what you want. In both cases, I'm using Vellum post-process to detangle in 10 passes, and then subdivision depth with Calumet-Clark. I think it's the same here as well. Yep, that's it. So that's that. Okay, let me just choose this one. Okay, I think this is pretty good now. Let's move on to the rendering part. Okay, actually, no, render drops. Okay, so I'm going to show you render drops here. Okay, so basically what I'm doing is here on the left side, I'm bringing out the box outer, which is the box outer. Okay, before I pulled it back in, and that's because I wanted these drops to be on the outside of the box rather, or in between the in and the out of the box. Okay, so that's why I brought in the box outer, and then I scatter a bunch of points here, 100, and then I create a group called box drops. And then on the right hand side, I'm bringing in the actual web. This is web 1. If you use method 2, then you need to change this to method, web 2. And then I'm creating an add node to delete all the primitives and just keep the points. Okay, delete geometry but keep points. And then I'm deleting 99.005%, and I'm only keeping this much. Really, I didn't. Yeah, it's too many points anyway. So, and then I'm creating a time shift, this is actually a very good trick if you want to know. So what we are going to do later on is use this for each node here. Okay, so if you bring in animation in here, this is gonna cook every frame. Okay, so that's why I don't want to do it. So I created a time shift, and I created a group called web drops. Okay, I combined them two, the box drops and the web drops. Randomize p scale. Note the global scale is actually 0.1. Okay, and I create orient again. Orient is an attribute that rotates the points, so each copy has a different orientation. Okay, so on this side here, I've got a sphere, which I'm using mountain to noise it up a little bit. And down here, I'm using one of those methods that we use for each loop. So basically, it says, get me the iteration value from detail of for each begin one metadata 1, which is this one here. Okay, and I'm saying, okay, when you get that iteration number, randomize that number and give me a number between 0 and 1. So basically, this offset will always be between 0 and 1, okay, because randomization is normalized, okay, and it gives you different result per iteration. So we have 130 iterations here, and every one of them will have a different offset. Hopefully, maybe some of them will have the exact same. I don't know. Right, and I'm copying the sphere onto the points. And I am creating this. Okay, so, and also make sure that I've packed it, an instance of it. Okay, and then what I'm doing here is splitting the web drops and the box drops, because remember, the box drops is static, but the web drops have to go in line with the web. So here's the web, for an example. Let me get rid of this. Bring that here. Okay, so there are the web drops. Okay, so if I now play this, you'll see that these web drops are not moving, and that's not very good. Okay, so what I did here was I created a point wrangle, and I'm basically saying your current position will be the current position of what's coming in the second input, which is 1 here, because it starts with 0. Okay, starts at 0. So the incoming position will now be converted to the incoming position in number 2, or number 1 here, our second input. Then now you'll see that it moves in line with the webs. Okay, so if I don't do that, how easily I'm scrolling here. If I were to not use time shift here and put this on here, okay, even here, if I do that here now, so it's about 3 frames per second, or yeah, something like that. Okay, and if I were to put the time shift on and this, it's 24 frames per second. Now you can see clearly the difference, and this is now 1.9 because it's simming in the background. The sim is not fully complete yet, but as you can see, it's 24 frames per second, so it's a significant difference. I'm using very less number of points here, but if you were to use, like, I don't know, 10,000 points, it'll get significantly slower. Okay, So that's why this trick is cool. Okay, so I've saved it and I'm unpacking it to apply the material. Although I'm packing it here, which I mentioned earlier. But I am unpacking it because I think Redshift don't like packed material. Okay. And I'm transferring velocity attribute. Okay. And then I'm giving it the drops material, which then takes us to the material network. So drops is basically water. That's it. And web, I used jade, which is subsurface scattering material. Okay, and I changed the color, and I'll explain that shortly. But nothing really else is, to note here really. And if you want to go through it, you can obviously grab the copy and have a look at them as well. Okay, that's the web, and then the box itself is glass. Okay. By the way, I'm not going to render box. Okay. But there is box. If you want to try it, you can switch it on and render it. It took about 4.5 minutes per frame, okay, because there was a lot of things to calculate, refraction, reflection, and whatnot. Particularly refraction takes quite a long time, so I ditched it for my animation. Okay, so that's what that is. I think we are good to go here. As far as the dome light is concerned, this is the same seller dome light from Polyhaven, which is available for free. So I'll leave a link in the description. Check it out. And I've also used IES lights. Again, these IES profiles are for free. I'll leave a link in the description again. As far as the camera is concerned, I used DOF, okay, depth of field. And I use the LUT, which comes with Redshift. Okay, and I set up the sampling based on where the drop is located. So let me go and put this back to 16. Okay, set up the camera, save it, and let me just run a few frames, and I'll show you render maybe the 24th frame. Okay, and we're kind of done after that. Okay, so there's the render. Just want to point out that it's very blue. And early on, before I started the project, I kind of decided that I'm going to go for Spiderweb and I'm going to make it black and white. Okay, and that's why the blue color, because I can choose the blue channel here and it looks a lot cooler. Okay, that also reminds me, one more point is that watch out for the web material reflection. Okay, I'm not sure how reflective webs are. I think it depends on the spider itself, but anyway, so I've given it very less reflection weight, okay, because it was too distracting. All right, so that's one of the points. Actually, I do want to mention another one. See, these droplets, I noticed that in Google search that webs actually do contain very small drops of water on each of these lines, like a lot of them. So basically I tried to create, what I did was I used another version of this. Let me just close that one, and I used non-selected, and I tried to do exactly this, but it kind of crashed my computer, so I didn't want to do that anyway. So you can try it if you want. All right. Well, the difference being why I created a separate one is so that the P scale can be much smaller. Okay, because these are big drops. You don't want big drops on each one of these lines. You want tiny drops. Okay, but it was too much for my computer anyway, so I kind of decided to ditch it. All right, so that's that. Okay, so this is the last thing I want to show you. So this is method 1 on the left hand side, and this is method 2 on the right hand side. Okay, I don't know how to run loop animations on Windows player, so I'm just gonna run it once, I guess, or I keep pressing play after. So you see how much it moves flawlessly. I think this is really nice physics to it. On the other hand, this one is a lot more stiff. Maybe you can adjust the stiffness for your pin method, but I prefer the first method. It looks nice. So, and also watch out for these reflections here. Okay, so that's the end of project walkthrough. Okay, I hope you learned something, and I hope you enjoyed. Please do check out my Gumroad page for other stuff. I've got a whole bunch of them in there. Please give me a like, a share, comment, subscribe. I would appreciate it. Till next time, have a good day.